basic concept. Firstly, here one example is given, and it says 3 car dealers each sell 3 models of a car. The table below shows the number of cars each dealer sold in a given month. So dealer 1, model A, 5, dealer 2, model A, 2. As you see, there are some informations about the cars and how many cars the dealer has sold is here. So this kind of informations, when you have more informations, we can use matrices to organize this kind of data. Okay, so as you can see, we can write this one as a matrix. The plural form of matrix is matrices. Singular form is matrix, this one. Matrix. So as you can see, these data can be written as a matrix. So matrices will help us, helped people to work with lots of data. So this is one kind of matrix. It can has more numbers and more data and more rows and columns, you know. Now in our lesson, what we'll do, we will learn how we can do operations with matrices. Okay, here I was checking for the video where is the applications of matrices, but all the videos are from Indian people, and you know their English is a bit funny, and I couldn't find an exact video how I was looking for. But if you want, you can search where is the applications of matrices. But they are really important. They have been used in business. They have been used in, how to say, circuits, you know, the electricity circuits, they have been used there. So the matrices are really important part. But now in our lesson, we will learn how to use matrices. How to work with matrices, okay? Now, as you see, here is the definition of a matrix. Matrix is a rectangular arrangement of numbers in rows and columns. In rows and columns. These are the rows. These are the columns. So here, as you can see, you can write as many numbers as you want. Okay, the horizontal lines of numbers in a matrix are called rows. And the vertical lines are called the columns. These are the rows, like this. And these are the columns, like this. You know from the word meaning. The number of rows and the number of columns determine the dimensions, also called the order of the matrix. Dimension. So for example, here if I have n columns and m rows, the dimension of this matrix is m times n, or n times m, okay? So how many columns, how many rows you have will give you the dimensions. You can write these words, what does it mean, okay? So a matrix with m rows and n columns has dimension m times n. Look, like this will show the dimension of the matrix, or this is read as m by n matrix. This is m by n matrix. So if you will have, here you have an example of a matrix. Look how many rows you have, 2 rows you have. How many columns you have, 3 columns you have. So this matrix is 2 by 3 matrix. So for example, in a question can be given you, there is a 2 by 3 matrix, and you need to know that there are 2 rows and 3 columns. So as you see, the first number will give you the number of rows. The second number will give you the number of columns, okay? Okay. Number and this one, each number in a matrix is called an entry. So A11 is an entry. Here look, Aij means the entry in the ith row and jth column. What does it mean? So A11 is first row, first column. let's say A21, it's second row, third column. Okay, so these numbers here shows you where is your entry, in which row and in which column. Okay, so you can write this one. For example, A13 is first row, third column. Okay, did you understand? These are the names, these are the words that we'll use when we'll solve matrices. Okay, we will have row, we will have column, dimension, entry. Okay, it's clear, this one?
Teacher, can you explain one more time about entry?
Entry, every number in the matrix is called entry. For example, here the matrix is given with an unknown, with a variable a. So A11, this 11 shows you the place of the entry in the matrix, in which column and in which row it is. So A11 says that this is in first row and first column. A33 says that this is in third row and in third column. So as you can see here, we have a matrix with numbers. So if I will ask you to tell me A, let's say 2, 3, which number is A23?
It will be second row, third column.
Second row, third column, which number it is?
0.
0. So A23 will be 0 in this matrix. What is A12, Salman?
5.
It will be 5. First row, second column. What is A21, Eva?
It will be
Second row, first column. Eva is frozen.
Where did you hear me?
Now, yes.
Teacher, my internet is not.
Yeah. You were frozen, like.
Teacher, can you explain this again because I don't get it?
Which one? This entry?
Yes, teacher, same for me.
Okay. Look, did you understand these rows, columns? Look, here, how many rows we have in this matrix? We have 2 rows. Yes, these are the rows. And how many columns? We have 3 columns. These are the columns, these ones. Okay, and these numbers here, let me say one more time, we have 2 rows. Let me take the rows with red. These are the rows. The red ones are the rows and the black ones are the columns. And every number in the matrix is called entry. 2, 5, 4, 6, 3, 0. They are the entries of this matrix. Okay, it's okay? But we have in entries, we have the, how to say, this one, index number, you know, the small ones, will show the place of the entry in the matrix, in which row and in which column it is. Okay, so here I have 2 rows and 3 columns. So when I'm writing first 2 and then 3, it means that the second row, third column, second row, third column is 0. So A23 will be 0.
Teacher, the matrix changes or not?
How you mean changes?
For example, in this case, we have 2, 5, 4 and 6,
Yes.
3, 0. In other cases, there will be different numbers.
Yes. They
Okay.
will be more rows, more columns, or less rows. You know, it will change. This is only one example of a matrix. This is 2 by 3 matrix. 2 rows, 3 columns. This is 2 by 3 matrix. Entries are these ones, 2, 5, 4, 6, 3, 0. So for the second one, for example, 1, 2, first number will show you the row, second number will show you the column. So this is first row. I'm taking this first row and second column. So which one is my entry? 5. Okay?
It's okay. It's okay.
Alexander? Kibariye?
Teacher, I didn't get.
Which part you didn't get, Alexander? Where is the thing that you cannot?
How teacher A23 is equal to 0, 8, 12?
It's not A23, it's A23, okay? So one more time, I'm repeating. These small numbers next to A shows you the row and the column, in which row and in which column you are looking for. So what?
Okay, okay.
Now, for example, A21, 2, you have first number as 2, means the second row. I'm taking, this is our matrix that we are working right now. I'm taking the second row, okay? And what it says here, the 1, it says that you need to take the first column. I'm taking the first column. And what is the intersection part of these two?
6.
6. So A21 is 6. Okay?
Yes, teacher, okay.
If it's not okay, please tell me again. I will not continue because if you will not understand this part, then it will be harder to continue for the next topics.
Teacher, can you give another example?
Yes.
Okay. Okay. Let me check if we have here. Look here, we have an example with that one. Look.
Can I try to solve it?
Yeah, another matrix is given here. Alexander, can you tell me the dimension of this matrix?
The third one, teacher. The third row.
The third row. Okay, this is the third row.
This is 3, 4.
This is the third row.
And what means 1, teacher? I forgot.
Column. The other.
This is the first 2, 5, 1.
Yeah, 2, 5, 1. So what is the intersection?
1.
1. So A31 is 1. I asked you the dimension of the matrix. How many rows we have?
3, teacher.
3 rows. I am right. Firstly, 3. How many columns we have?
3.
Are you sure?
No, 1.
1, 2, 3,
4.
4 columns we have. How many numbers do you have here? 1, 2, 3, 4. So this is 3 by 4 matrix. Okay?
Okay.
Varia, what about B, A23?
So, teacher, sorry. So the number which is in both circles is the.
Yeah, the one that we are looking for.
Okay.
Yes, Kibaria?
The second row and the third column.
Second row is this one, 5907. Which one is the third column?
From 4, I think.
404. This one. So what is the intersection of them?
0.
0. So A23 is 0. Okay?
Yes. Now I get the teacher. Thank you.
Okay. Fatih, what will be C?
It will be 9.
It will be 9. So let's see, third row,
Yes.
fourth column. So it will be 9. Okay.
Can I try D?
Hi, Alexander.
It will be second column, 5907.
5927.
And also the second, 090.
Yes.
It will be 9.
And it will be 9. Okay? Did we,
Okay.
what
Now,
is
yeah.
entry and how we are finding the entry and the rows and the columns? It's okay?
Now, yes.
Okay. By the way, while you're writing, let me take the attendance. Alexander is
Here.
here. Eva
I'm here, teacher.
here. Yona? No. Ermal? No. Fatih?
Here, teacher.
Here.
Arta? Arta? No. Arta is not answering. Giovanna?
I'm here.
Stanislav?
I'm here, teacher.
Salman?
I'm here, teacher.
Salman is here. Rumeysa?
Teacher, can you hear me?
Yes, Arta, I can hear you now.
Because I talked, but I think you didn't hear me.
No, your voice was closed. Rumeysa? Rumeysa is here. We cannot hear you, Rumeysa, but I can see you. Besan?
Yes.
Besan is here. Okay. Again, some of the cameras are closed. I don't want to warn again for the cameras. No. Now, if you have written this one, I will continue. Now here we have types of matrices. As you can see, we have 8 types. It won't be very understandable directly from now, but at least try to remember the names, okay? First type is square matrix. Square matrix. What do you think? What can be square matrix?
To form square by
To form square. In squares, what we had, all the sides, they were same. Do you remember?
Yes, if it is 2, also the columns will be.
Yeah. So
2 by
here
2,
the
3 by
number
3.
of rows and columns will be equal.
The
So
dimension will be 3, 3, 4, 4,
yes,
5, 5.
yes, 2 by 2, 3 by 3, 4 by 4. So square matrix, as you can see, as we said, will be the rows, the number of the rows and the number of the columns will be the same as it's given here. This is 2 by 2, this is 3 by 3, so you may have 4 by 4. These kind of matrices are square matrices. Zero matrix, what do you understand from the name of it?
Only have zeros.
All the entries, yeah, all the entries are 0 here in this kind of matrix. We're not talking about dimensions, we're talking about the entries. If all the entries are 0, we call it zero matrix. Identity matrix. Identity matrix. Look here. We have 1. Here you have, in this case, look, it is like square matrix, but the entries, as you can see here, like it goes in this way, all of them, they are 1 and the others are 0. Always it will be like this. It can be.
Also, one more thing, teacher, it can be A11, A22, A33, A44. Is it like that or not? The entries.
Yes, A11, A11, A22, A33 is if your matrix is 3 by 3. They are all ones. The other entries are zeros. Okay, but
Okay.
in identity matrix, you have square matrix. And the entries, as you said, A11, A22, A33, A44, if you have 4x4 matrix, it will be all ones, the others will be 0, okay? And this is called identity matrix, and mostly we will show this matrix with I, like this. If in an operation is written I, it means that this identity matrix and the entries will be in this way, okay?
Okay.
Teacher, must the ones be diagonal, for example, or not?
Yes, yes, yes. Yeah, they have to be diagonal.
Okay.
Here, the fourth type, diagonal matrix. As you can see, diagonal matrix from the name, the diagonal ones, I mean, the entries that are on the diagonal will have some values. The others will be 0. Okay, but here it's not like an identity matrix. You don't have to have always ones. You may have different numbers, but the values on diagonal will be some other values. The others will be all 0. The other entries will be all zeros. Okay?
Okay.
Okay.
Scalar matrix, as you can see, again, it's a kind of diagonal matrix, but it's the diagonal entries will be the same. -5, -5, 7, 7, 7. You know, look, A11, A22, A33, they will be all equal to each other in scalar matrix. Okay?
Yes, teacher.
Okay.
And the symmetric matrix, it's symmetric. We have the diagonal, and the other values, other entries are symmetric, as you can see. 2, 2, 0, 0, 5, 5. The diagonal is here. The other entries are symmetric, same.
Oh, okay. Okay.
Okay? The diagonal part, it's the line, let me say, the boundary, and the other entries are symmetric to each other. It goes 2, 2, 0, 0, 5, 5, okay?
It's okay.
Antisymmetric matrix, look here, the diagonal part you have, but the others are the opposite of each other. What I mean opposite? With signs. If one +2, -2. 1, -1, -3, 3, 5, -5, okay? This kind of matrix is antisymmetric. And triangular matrix. Triangular matrix, as you can see, you can find here a triangle. Look. And these entries are all 0. Or this one. Look. This is a triangular matrix. It's okay.
Sure, but why do we need this many names? I mean, matrix is matrix.
Maybe, you know what? Maybe in some questions, it will be written like A is a triangular matrix. And you will know that in one part of the matrix A, you will have zeros. Okay? Now I am giving only, I mean, by solving the questions, you will see better. You will understand it better. For now, the important part is when you say square matrix, if you understand that the rows and the dimensions, the other columns are the same, and the identity matrix we'll use really often, that the diagonal entries are 1, the others are 0, and the other ones, I mean, you will not see very oftenly, but you need to know the names, at least, to see once the names.
Okay.
Teacher, can the matrix be like combination of 2 of them, for example, or not?
What you mean, 2 of them?
For example, triangular with
many names, combination of 2 of them, like in one matrix.
In one matrix, what to have? Scalar matrix and let's say symmetric?
Yes, teacher, for example, then yes.
But it won't be. It will be another matrix, because in scalar matrix here I took the scalar matrix. It is a bit like symmetric because they have zeros in both of them. You know, So the
Yes.
matrix and identity matrix, they are the same because, but in identity, what is the diagonal? It's all ones. But in the other one, you may have different values. In that case, you will not call it identity, you will call it diagonal matrix. But also identity matrix is a diagonal matrix. Yeah?
Yes.
Yes.
It goes like that. Now, if it is okay, we have one more, the ninth one, communication matrix. Matrix. Look, there are some, it's given a figure to you and you need to write it as a matrix. Okay? So here there are some connections between the computers. And when we'll write this one as a matrix, what we'll do from computer to computer. The rows will be from, the columns will be to. So how many computers we have? 4, A, B, C, D. We are writing the rows and then the columns. We are writing A, B, C. Now I am checking from computer A to computer A. Is there a connection?
From A to A. What?
There is no. So it is 0. From A to B. Is there a connection from A to B? From A.
Yes.
Yes.
Okay, it's like in informatics, yes and no.
Yeah.
No's are 0, yeses are
Yes, yes.
okay.
From A to C, is there a connection from A to C?
Yes, 1.
Yes.
From A to D? No,
No.
0.
No.
From B to A backwards, there is
0
No.
because there is no
yeah.
connection.
From B to B,
No.
No.
from B to C,
Yes.
yes, 1. And from B to D,
Again.
Yes.
1. So you are forming this matrix in this way. There will be given a connection here and you will write it as a matrix. Okay? This
Okay.
communication matrix. It's okay? Can I continue?
It's okay.
Yes, it's okay.
Okay. Now, as you can see, there is an example. A connection is given here. A network is given. And we need to write a communication matrix P for this network. Now, how will form the matrix P? We have P. And how many connections we have? A, B.
We have 5 with 5. The dimension
Yes.
should be 5 times 5.
So let's write it A, B, C, D, E.
Yes.
E, E. And also here, A, B, C, D, E. We show the matrices with these parentheses, the big ones. Now, from A to A, is there a connection?
No,
No.
it's 0.
No, 0. From A to B, Alexander?
Yes, teacher.
So what I will write here?
1.
1, okay. From A to C, Arta?
Yes, teacher, it's 1.
It's 1,
A to C.
okay. From A to D, Eva?
No, teacher, it's 0.
No, it will be 0. From A to E, Stanislav?
Good question, teacher. No, I don't know.
Directly. Do we have a connection from A to E directly?
No, teacher. So
So it
0.
will be 0, yes. Fatih, from B to A?
No, teacher. 0.
No, it will
Okay,
be
now
0.
I understood it, teacher. Okay.
Okay. Kibarye, from B to B? Kibarye?
No, I think.
No,
Zero.
there's no anything like this. You know, to itself, it doesn't go to itself. So it will be 0. Rumeysa, from B to C, is there a connection from B to C?
From B to C, no.
No, so it will be 0. Okay. Now, Salman again. From
Okay.
B.
from B to D, there is a connection.
There is a connection.
Yes, one, yeah.
1 from B to E.
Me?
Giovanna,
Yes, teacher, there is.
it will be 1. So now tell me the numbers. I will not ask one by one. What will be this one here?
From C to A, 1.
1,
From C to
One.
B,
1,
1,
0,
0.
0.
Yes, 1.
1,
And
Okay. And 1. Now this one?
0,
0
Okay.
1,
and 1.
Okay.
0,
0,
Okay.
0, again,
0, and 1.
and 1.
And 1. And the last one?
0,
0,
0,
0,
1,
1.
1,
From E to
again,
0,
this is 0, and the last one is 0.
Okay. So did we understand
Yes.
Yes,
how
teacher.
we are forming this matrix? If it says application matrix and there will be a network or connections like this, it has to be given. And then according to that connection, you will form your matrix. Okay?
Teacher, are we going to need this in our daily life or not?
Daily life.
Our real life?
Where you want to see this one? When you will
I don't
go
know. Are we going to see it or not?